Hello and welcome to AP Macroeconomics with me, Mr. Sanabria. Today's lesson is an introduction to the production possibilities model. Before we get into talking about the production possibilities model, what we do need to have is a quick discussion about models in general. And what I mean by a model is a graph. So what models are used for is simply to illustrate complex ideas. So sometimes we can use words to simply discuss an idea and a very complicated idea. And what we'll find is if we can actually understand a graph, we can communicate an idea that's really complicated. It might take us 20 minutes to describe using words. We could illustrate it almost instantaneously using a graph. But in order to do that, we have to understand graphing in the first place. We have to have a foundational understanding. And I know that many of you, probably all of you actually, have a foundational knowledge of graphing because you've had math classes that have taught that to you. What I need you to understand, though, is that we're going to be using graphing not for the mathematical usefulness of determining slopes and correlations and things like that. What we're actually going to be using graphs for is to model theory. And so we need to think about what a graph is actually telling us. So let's go ahead and start off with basic understanding of what graphs are. They are starting from a Cartesian plane. That's what this is called. And you have two axes, and you need to know them. You have your x-axis and your y-axis, right? So you have an x and y-axis, and if you can't remember that, you need to be able to remember it, and I have a very useful little tool that a student taught me, actually. If you go to the airport and you're in a plane, and you're just driving around on the runway, all right, it's called taxiing around, and then eventually you're going to fly up into the air. So you have taxi and fly. Boom. Mind blown. So if you don't learn anything else today, at least you will never, ever forget the difference between the x and the y axis. But we actually have a lot more complicated things to learn today, I think. So we're going to move right along. So let me go ahead and get our axes labeled back up again. And I'm going to put them in red here so that we don't get anything confused. So you have your x and your y axis. Now, in economics, we're really only concerned, and I guess I can take my flight path off of here. We're only concerned with things that actually exist. So what's good about this course is that I'm taking all of this Cartesian plane in all four quadrants, and I am only going to be concerned with things that actually exist. And what I mean by that is we are only going to be using the positive quadrant, where the values on both the x and y axis are positive. So now I can deal with, in a situation where I have something like 1, 2, 3 of whatever y is, and 1, 2, and 3 of whatever x is, well, maybe they have a positive relationship. And so there's another word we want to talk about. What is a positive relationship? A positive relationship is if one variable, in this case, if y increases in value, the other variable, in this case x, increases in value as well. So you see that they go from being 1 and 1 to 2 and 2 and 3 and 3. They have a positive relationship, or you could say they're positively correlated. A negative relationship would look like this. So as you get a little bit more of good x, we'll call it, you get less of good y. If you get more of good x, you got a little less of good y. And if you get even another good x, you got even less good y. So the more you have of one, the less you have of the other. That's called a negative or an inverse correlation. So we've got three different terms that we want to talk about here. We have the idea of a positive relationship. We have the idea of a negative relationship. And the fact that a relationship exists at all means that there is a correlation. Okay, so a correlation can either be positive or negative. Now, what you end up seeing, if you want to talk about this in mathematical terms, is you have an upward slope or a positive slope. And if you wanted to talk about this one, you would say you have a downward slope or a negative slope. Okay, so that's just a little bit about graphing. Now, I've already started to use the language of variables, right? I said the variable x, the variable y, and in math you talk about variables in terms of x and y all the time. But what we're going to do in economics is we're going to talk about real stuff. And so let's go ahead and have a conversation about two of the things that I like the most, which is breakfast tacos. And I am going to talk a lot about breakfast tacos in this class because they happen to be just the best thing to describe every situation. I don't know how they made that happen, but breakfast tacos are the best example for everything. So we got breakfast tacos and cars. Okay, that's two things I like. I like cars a little bit, not as much as I like breakfast tacos, but those are your variables. So if I were to go ahead now and graph the relationship between breakfast tacos and cars, I might do this. And for the sake of argument, let's just say this is a straight line. And what I'm saying here is that somehow there is a negative or inverse relationship between breakfast tacos and cars. Does that make sense? So what are we doing? What we are fundamentally doing is comparing the relationship, or in this case we have illustrated the relationship between two variables. And that's what graphs are about. Graphs illustrate the relationship between two variables, and you need to understand that. So if I say, hey, what is this graph saying to us? A perfect answer would be, well, Mr. Sanabria, it's illustrating the relationship between breakfast tacos and cars. I didn't know there was a relationship between those two things, but that's what the graph is illustrating, and I would say, yes, perfect. I'd probably even give you a sticker if I was there. So here's the deal. We've actually started with my seemingly absurd breakfast tacos and cars model here. We've actually begun our first production possibilities graph. So the first thing I want you to know about the production possibilities model is this. There are a number of names that the production possibilities model goes by. And you need to just recognize that they are all the same. They do have a reason for having each of these names, but the names don't tell us anything important. But what you do need to know, and what you are responsible for, is actually recognizing the production possibilities graph regardless of the name that you see. So the first thing is production possibilities model. And this describes the entire model. It's a production possibilities model. But you might also see the production possibilities frontier. Production possibilities frontier. Now, what's a frontier? Well, a frontier is a border. Remember the old frontier, the Wild West? In fact, I've got a tissue box here that I'm using as a whiteboard stand that's got pictures of cowboys. The Wild West, the frontier, the border. Okay. You might also see the production possibilities curve. Now, a production possibilities curve is the exact same thing. So what is a curve? Well, a curve is any line connecting points on a graph. So coming back over here to what we just drew, breakfast tacos and cars relationship, what we did was we drew a line on the graph. Now let's assume this line is straight. It's still a curve. So yes, a straight line can be a curve. Any line on a graph is a curve. Now, those were all really long names, and it took me a long time to write them out. And so a lot of times we shorten them, and we have these other two things that we could call them. We could call these simply a PPF or a PPC. So those are the next two I just wrote. PPF, PPC. Of course, PPF stands for Production Possibilities Frontier. and PPC stands for Production Possibilities Curve. So all 5 of these names mean exactly the same thing. We are referring to the Production Possibilities Model, which we are finally now going to dive into and talk about what exactly we need to know about the Production Possibilities Model. So going back to what we started before, I told you we had started a Production Possibilities Model here. If you were to think about this really hard, what this would be telling you is that you can either have this many breakfast tacos and no cars, or you could have this many cars and no breakfast tacos, or you could have this many breakfast tacos and cars. So what this is illustrating is, as the name suggests, what is it possible to produce? To create, to build, to manufacture. What is it possible to produce? Let's put some numbers on this so that we can start talking, we can quantify some things. So I'm going to put 10 and 10. Okay? So in blue there you can see 2 10s. All right? So I can either have 10 breakfast tacos and 0 cars. Or I can have 10 cars and I can have 0 breakfast tacos. So what if I only wanted 5 breakfast tacos? Well, in this case, now, according to the graph, I could possibly have 5 cars. What did I do? I traded, basically with myself, through the decision of what I would produce, I traded 5 breakfast tacos for 5 cars. Now, what if I wanted 6 breakfast tacos? How many cars could I have then? Take a second and guess. Alright, time's up. You would actually have the ability to produce 4 cars. So, for those of you who are super mathy out there, what you've probably realized is, yeah, because this curve has a slope of -1, which means rise over run. -1 over 1, right? For every another car that I have, I give up 1 breakfast taco and vice versa. It will always be like that. I could draw all the way from 1 to 10, and you would see this 1-for-1 exchange. Now that 1 breakfast taco that you give up for 1 car is actually the opportunity cost of building a car. So what have we just done here? We've just illustrated opportunity cost. And if you recall, we talked about opportunity cost last time, and we said the opportunity cost is the real cost of something. It's the value of the next best thing you give up when you make something, or you choose to do a decision, right? Well, in this case, what we gave up was 1 breakfast taco in order to get 1 car. So, what if, instead of it being 1-to-1, and I'm going to have to fix this up just a little bit. Let me just go ahead and draw a new curve. What if instead of it being 1-to-1, it was more like this? Now, instead of 10 breakfast tacos and 10 cars being possible, what we have is 10 breakfast tacos or 5 cars that we could create. So now all of a sudden, what we have noticed, hopefully, is that cars have become more expensive in relation to breakfast tacos. So I can either have 10 breakfast tacos or 5 cars. So if I were to go from having nothing but breakfast tacos to having 1 car, how many breakfast tacos could I have? Well, if you answered 8, you would be correct, because now I have to give up 2 breakfast tacos for every 1 car. The slope of this line is -2. So you can see now that the opportunity cost for a car is 2 breakfast tacos. What's the opportunity cost for a breakfast taco? Time's up. It's actually half a car. If I want 1 more breakfast taco, if I want that 9 breakfast tacos right there in the middle, then I have to give up half of a car. Does that make sense? So here's where we're at so far. We understand what the production possibilities curve is telling us. It is telling us literally what's possible to produce. And maybe now we can understand why it's called a production possibilities frontier as well, because a frontier is a border, right? And beyond this red line, this is the zone of impossibility. We cannot possibly produce at that level. So why is there a frontier? Why is there a limit to what's possible at all? That becomes our next question. Why does this frontier exist in the first place? Well, we've already learned about this concept last time too, and that concept is scarcity. So remember, scarcity is the simple truth that everything is limited. And when we talk about everything, what we're really talking about are the economic resources, which we learned last time, which are land, labor, capital, and entrepreneurship. So because we only have so much land, labor, capital, and entrepreneurship, at a certain point, we run out. And it's only possible to produce a certain amount. If we used every single resource at our disposal, and I mean every single resource, we could make 5 cars. Well, of course, there was nothing left over to make any breakfast tacos. Similarly, if we used every single resource at our disposal to make breakfast tacos, there would be nothing left to make a car, and we would be able to have no cars. So what we would have to end up doing is making trade-offs with ourselves. Okay, we want some cars and we want some breakfast tacos, so maybe we decide to make 3 cars, which gives us the ability to make how many breakfast tacos? Well, 6. Does that make sense? Because we ended up having to, actually it'd only be 4 now that I'm doing my math. That's a 4. So in order to make a car, for every car we made, we had to give up 2 breakfast tacos. So the first car allowed us to make 8 breakfast tacos. The second car allowed us to make 6 breakfast tacos, and then the third car gave us or left us with enough resources to make 4 breakfast tacos. So we've illustrated a lot of really complicated topics with this simple line. So let's go back to the beginning. Where did we start here? Well, we just started with a positive quadrant. We added 2 variables, breakfast tacos and cars. We quantified it a little bit. I said 10 and 5, and I drew a line. And simply doing that, we illustrated everything that you see here except for item number 3. Let's just talk about 1 and 2 for a second. We talked about scarcity, limited resources. We talked about opportunity cost, the value of what you have to give up when you make a decision. Okay? And now we're going to talk about the idea of efficiency. Okay? And efficiency is defined as simply how well you're using the resources at your disposal. So let's go back to our graph. What if I were to tell you that this is only an illustration of what's possible? You would probably say, yes, I know, because it's called the production possibilities model. And I would say, okay, well, we're on the right track then. So what does that mean? It means I don't know what we're doing. I just know what's possible. So now I'm going to put a dot somewhere on here, and that dot is going to represent what we're actually doing. So let's say I put the dot right here on the line. What that means is we are actually producing 3 cars and 4 breakfast tacos. What this means is we are producing as much as possible. We are efficient. This dot represents efficiency. Because we're using every possible resource at our disposal. All of our land, all of our labor, all of our capital, all of our entrepreneurship. There are no factories that are not working. Okay? Every factory is working. Every person who should be employed is employed. Every resource that could be employed is employed. But what if I were to tell you we were actually making 4 breakfast tacos, but only 2 cars? Well, if we're only making 4 breakfast tacos, we've got the resources to make a whole other car. We're not using our resources efficiently. This is called inefficiency. any point of production that is inside the production possibilities frontier is inefficient. There's an inefficient level of production. There's some resources out there that are not being used. So finally, what would this tell us? That would be impossible. That is impossible. And we're going to caveat that and say, for now. That is impossible for now. We don't have the ability to produce at that level. We cannot have what looks like 10 breakfast tacos and 5 cars. We can't have 10 breakfast tacos and 5 cars. The resources don't exist. We can't do it. Okay? So, let's recap a little bit. The production possibilities model takes 2 variables and it compares how many of each we can make. Then there's an actual curve or a frontier of what's possible. If you're producing on that frontier, you're using all available resources. Let me come back to this real quick and clear something up that many of you might be asking yourself. Well, is it just as efficient to make 10 breakfast tacos and no cars? Yes, that's just as efficient, and it's just as efficient to make 5 cars and no breakfast tacos. What's important as far as efficiency is that you're on the frontier. We don't care that it might be a really bad decision to make only breakfast tacos and no cars. I mean, that would be normative economics. Positive economics would say, listen, as long as you're using all of your resources, it's efficient. Okay? So, you might think at this point, well, that's all well and good, but when are we going to learn something that we can actually apply in some sort of a real way? And what I would say to that is, you are absolutely correct. There are a few things about what we just talked about that don't make much sense at all. Not the least of which is we're comparing breakfast tacos to cars. Certainly there is something a little more useful than breakfast tacos and cars. So since this is a macroeconomics class, a class in which we're going to talk about the entire economy, what we want to do is somehow break the entire economy into 2 groups that we can compare the same way we just compared breakfast tacos and cars. And this is how we're going to do it. On the y-axis, we're going to call that consumer goods. And on the x-axis, we're going to call that capital goods. And it's going to look something like this. Now we've got consumer goods and capital goods. So consumer goods are those goods that are finished. Remember, we were just talking about the factors of production, and we talked about capital and what capital is. And I said, well, those are those things that are made by people. Land plus labor equals capital, right? It's made by people, but it's not done yet. It's not the finished product. It's something that's going to help us make a finished product. Well, consumer goods, those are those finished products. Breakfast tacos, for instance. Cars, for instance. Capital goods are then all of those items that are made, but they're made in order to make a capital good, or a consumer good, I'm sorry. And so what you end up with is a good way of splitting up all the things in the economy. Some things are produced in order to help us produce other things, and some things are produced because that's the thing we want. And so the next part that was not very realistic was this idea that the trade-off from if I'm going to make nothing but, let's start talking in consumer goods and capital goods now. We'll move away from breakfast tacos and cars. Let's say if I was making nothing but consumer goods and I wanted to make one capital good, it's just a 1-for-1 exchange, right? Well, that's how it was on the pizza. Or maybe with the pizza it was a 2-for-1. But that exchange never changed the whole time. And that's because the slope was straight, right? It was a straight curve. Well, that's not realistic. The way that these curves actually look is something like this. That is curved. That is bowed out. That is actually what we call, the verbiage for this is concave to the origin. The origin is right here, 0. And if you were standing at 0, it would look like you were looking into a cave. It is concave to the origin. And what this is illustrating is that opportunity cost is actually increasing. So the opportunity cost moving from one to the other increases the more you make. And in order to illustrate this, I'm going to pretend like we can only make 4 of each of these. And I'm going to line this out as evenly as I can. you see we've got 0, 1, 2, 3, and 4. And I'm going to use my red marker so you can really see this. Let's say that we are going to be efficient through this whole process. And we start off making 4 consumer goods. How many capital goods can we make? 0, right? Well, we want a capital good, right? We have to have a capital good. So we want 1 capital good. So we kind of draw our dotted line up here as best we can, and we draw that over here. And what do we notice? We made a capital good, and we only had to give up a very little bit of consumer goods. We only gave up this much. It's so small you can barely even see it. This was the opportunity cost. The opportunity cost of making 1 capital good wasn't even an entire consumer good. So you say, oh, these are pretty cheap, right? I'm going to make another one. I want 2 capital goods. So that's what it ends up looking like. Now, right now, we're making 2 capital goods and we're making 3 consumer goods, and that seems pretty good, but what I really want you to focus on is the opportunity cost. This cost is smaller than that cost. The opportunity cost increased because we made another one. What would happen if we thought that, well, since these are so cheap, let's just go ahead and make a third? Looks like that. The opportunity cost of the third capital good was an entire consumer good this time. And finally, the opportunity cost of making a fourth is actually 2 consumer goods. This has a name, and this is a name that we need to know. This is vocabulary that we have to know, we have to understand. It is a law. It is the law of increasing opportunity cost. The law of increasing opportunity cost. And what the law of increasing opportunity cost tells us is that for every next good that you produce, you must give up more of the other than before. For every next good that you produce, you must give up more of the other than you did before. So what we're really talking about is the marginal opportunity cost increases. Remember, there's that word marginal again. Marginal means incremental. The next one costs more than the last one. And if I were to ask you to describe, and I will, what is the law of increasing opportunity cost telling me? You can't just tell me what opportunity cost is. You can't say, oh, it's the cost of, it's what you had to give up whenever you chose to make another one. Yes, that's true. That's opportunity cost. But the law of increasing opportunity cost tells us that that cost, the amount you have to give up to make something, increases the more you make of it. So the more I make of capital goods, the more and more consumer goods I have to give up. And that is what this curved frontier tells us. If this were a straight line, it would be the same. So you know instantly, just from looking at this, that this represents the law of increasing opportunity cost, and opportunity cost in real life is increasing. So now we've taken our old model that was breakfast tacos and cars and not very realistic, and it had a straight line, and the opportunity cost was 1 car for 2 breakfast tacos the whole time. Now we've turned it into something very, very realistic. We are now talking about consumer goods versus capital goods. We're now talking about increasing opportunity cost. So why is increasing opportunity cost true? And by the way, if I ask you to draw a production possibilities model, this is what I want you to draw. And you need to be really careful. I want consumer goods on your y-axis, and I want capital goods on your x-axis, and I want a curved frontier. And we'll practice that. But why does opportunity cost increase? Well, simply put, not everything is equally well suited for making everything else. And what I mean to say is this. Let's go back to pizzas and cars for a second. We weren't talking about pizza at all. We were talking about breakfast tacos. Let's go back to breakfast tacos and cars. I like pizza too. If we were making nothing but breakfast tacos and we were on the frontier, then we would be efficient, but we would only be making breakfast tacos. And what that means is, imagine the classroom you're in right now, or maybe you're not in a classroom, maybe you're at home, but let's imagine you're in class and your classroom is its own economy, and all we did was make breakfast tacos. Well, some of you would be really good at making breakfast tacos, and some of you would be really, really awful at making breakfast tacos. So some of you might make 5 breakfast tacos in a day, and others might, only make 1, or maybe even none. Maybe you try all day, and no matter how hard you try, you just cannot make a breakfast taco. That's a shame. But that's the case. Not everybody's going to be equally well suited. Well, what if the person who was worst at making breakfast tacos was also the best at making cars? Well, if we decided that the thing we wanted to do was make a car as well, then we would take you terrible breakfast taco maker, who's not contributing much at all, and we would move you over to making cars, and we would discover, oh my goodness, you made a whole car. So we didn't have to give up very many breakfast tacos at all, did we? In fact, you only made 1 or maybe none, so we didn't lose any breakfast tacos, or maybe we lost 1 breakfast taco, but we got a whole car out of it. It didn't cost us very much. But as we decide we want to make more cars, we have to start taking people who are actually good at making breakfast taco. The cost becomes greater. And so eventually, if we keep feeding our need for cars, we're going to have to take our best breakfast taco maker off of making breakfast tacos, and we won't have any breakfast tacos. So the opportunity cost gets bigger and bigger and bigger every next car we make. So each car is more expensive than the last. And we've really got to internalize this. And some of the videos that I've posted in the reading that's also included on the website here, they go into explanation of this in a different way. And hopefully, once you read and you consume all of the material on the website, the way that somebody explains it's going to be the way that clicks for you. So hopefully you get it. Now, if not, look at the other stuff. Read the reading. Watch the videos, and hopefully you will understand it. So I'm going to close today's introduction to production possibilities with the idea of efficiency. And this is where we're going to spend most of our time next time. But once again, if we are on the frontier, we're efficient. If we're inside, we're inefficient. And if we're outside, that's unattainable. We cannot accomplish that. But we're drawing this for the real economy. This is the actual model. This is the model itself. We can call this the production possibilities model for the United States. And what these dots represent then is where we are in what's known as the business cycle, which we'll talk about later, but we're just going to talk about now in terms of recession, healthy, and by healthy, what I really mean is full employment and full production. And out here, it would be unattainable. But I'm going to put for now, because guess what? We might get there one day. So that is a dot that represents an economy in a recession. This is a dot that represents an economy at full employment and full production. And this is a dot that represents an economy that really can't exist. That represents what's unattainable, what we cannot accomplish yet today. And now I'm really going to freak you out right here at the last minute. I'm going to suggest there's one more place you can be in the economy. You can actually be just outside the curve. And that would be an inflationary economy. So here are your different economic conditions on the production possibilities model. And we're going to pick it up here next time, where we're going to talk about what all these things mean, and we're even going to get to how you might actually get out here to what's unattainable for now. But until then, that's all for today. Good luck, and I will see you next time.